So we select a camera object and go to its properties. The very first button indicates whether the camera is enabled and participating in the solve. We can also disable it here, and that status will be reflected over here. Right now, we can see the camera is disabled. What does enabled or disabled actually mean? When you have multiple cameras in the scene, you can exclude one of them from the solve. For example, if you're tracking a scene shot from multiple cameras and one of them is not very reliable, maybe it's introducing errors into the solution, you can simply turn it off. Because during solving, all cameras work together helping the solver. But if one of them is causing problems, you just disable it. So if a camera is disrupting the solution, you can enable or disable it using this button. Identifier is the name of the camera. If you have multiple cameras in your project, you should definitely name them properly. Otherwise, you'll get lost sooner or later. And just like in any professional software, keeping your project organized is important. It says a lot about you. Not just as an artist, but as a disciplined and responsible person. So, naming your cameras and giving them clear, custom names, that's a good habit. Especially when you import a lot of source files and all the cameras are named after the original file names. If those names are just generic numbers or file IDs, then yes, it's definitely worth renaming them. Next, we have camera type, which defines the type of camera object. Sequence, a series of frames, an animated shot, reference frame, a single still image used for reference. That's essentially how they differ. That's the main difference. All other settings are identical. The only distinction is that a sequence camera is the main one and a reference is just a supporting still image. These two types don't differ in terms of settings. Functionally, of course, they serve different purposes, but all the properties we'll look at next apply to both sequence cameras and the reference cameras equally. The next parameter is weight. What is weight? Actually, you'll see this parameter not only in camera settings, but also in other areas of the program. For example, in point settings. So what does weight mean? It's how much trust we place in this object. Say we have multiple cameras involved in a scene solve. One of them has clean, high-quality footage. All the points track well. That's a camera we trust. Then we have another camera, let's say, a GoPro, with lower image quality, maybe some smoke or other issues. Clearly, even though both cameras are part of the same scene, we trust the information from one of them more, so we shouldn't treat them equally. The second one is more like support, to define which camera we trust more or less. That's what the weight parameter is for. What values can you assign for weight? The default is 1, but overall it's a relative value compared to other objects. If we have two cameras with a weight of 100, the program will treat them equally in the solve. If one is set to 100 and the other to 1, then clearly the solver will trust the one with 100 more. If one has 1 and the other say 0.01, then obviously the first one will take priority. So weight works in relation to other cameras. By default, it's set to 1. For the rest, you can raise or lower the value whatever suits your need. The next parameter is frame range calculation. It tells the program which frame range should be used to solve the camera to calculate its motion. By default, this option is disabled and the camera is solved over the entire loaded sequence. But there are cases where we need to solve the camera only over a specific section of the shot. There are a few cases where this might be useful. The first and most obvious, your sequence has a main section, but also some extra frames at the start or end they're not helpful for solving, and you probably just waste time on them. Let's say those frames aren't even used in the edit. So we simply limit the frame range, and only that part will be calculated. The second use case, we're tracking some complex camera motion. For example, the camera moves forward, then suddenly turns, and then moves forward again. So it's not a single motion throughout. As we mentioned earlier, understanding the type of camera movement is very important. If the shot starts with parallax motion and then the camera suddenly stops and just rotates in place, the program kind of freaks out. It doesn't understand why the parallax suddenly disappeared. That's exactly where frame range calculation helps. We separate the shot into phases with different types of movement, solve each one independently, and then stitch them together. That's how it works. It does matter how the camera moves, and in complex moments, we need to guide the program and manually stitch together different segments. That's how it works. We tell it from which frame to which frame the solve should happen. And when we solve for a specific frame range, no calculations are done outside of that range. Those frames simply keep the previous values that were calculated earlier. But when the parameter is disabled, the entire frame range is used in the solve. The next block of parameters is live action footage. Let's move on to it. In this section, we load our source material, either the main sequence or reference frames. The first parameter is main. This is where we load the primary footage we'll be working with. You can also load a proxy here, and I'll explain in a moment how that works. I hope that even those of you already familiar with the 3DEqualizer interface will find some useful details in this video. Things you might not have known, or maybe you guessed at, but weren't fully sure how they worked. So even if this isn't all new to you, I hope you stick around. I think you'll still learn something new. We load the footage by clicking Browse, and a dialog window like this appears. You might think, why even explain what a dialog window looks like? But that's the thing with 3DEqualizer. It's not like other software. What should you pay attention to? Yes, overall it looks pretty rough, but at the same time, it's actually quite clear. Navigation is on the left. Here we select the folder that contains the footage we want to load. And again, this brings us back to the fact that 3DEqualizer isn't exactly user-friendly. It won't hold your hand. For example, it works with image sequences, but it handles video files pretty poorly. So here's what happens. We load the file, but nothing shows up. That's why before you start tracking, you'll need to prepare your sequence, convert it using some external tool, whether it's Nuke or anything else. It doesn't matter. To avoid navigating manually every time, you can double-click on a folder that you frequently return to. It gets added to a kind of favorites list, which you can expand and quickly jump to the desired folder. It gets added to a kind of favorites list, which you can expand and quickly jump to the desired folder. We can view either the sequences as a whole or as individual files. Yeah, that's something you'll find in other programs too. 3DEqualizer reads most sequence file formats. It works well with EXR, JPEG, PNG, and TIFF files. It can read DPX too. We select the sequence. If we're unsure, we can preview the image here. And there's some additional info. Resolution, bit depth, date, that kind of stuff. Once the sequence is selected, we click OK. The sequence is now loaded into the camera. Let me quickly explain how to work with proxy. Let's say your source footage is very large. In my case, it's 3840 by 1610, but it could just as well be some 8K video. And tracking it at full resolution might be unnecessary. Maybe there's barely any movement, or 8K is just overkill for a shot like this. In that case, you can create a downscaled version of the footage, for example, half the original resolution. Or you could make a high-pass version where only specific details are emphasized and loaded into the sequence. So how does working with footage in 3DEqualizer actually work? When you're tracking a point, say I'm tracking the base of this antenna, the coordinates that the program stores for that tracker aren't exactly what you might expect at first glance. They're not just pixel values along X and Y, as you might assume. Instead, the X and Y coordinates of the tracker are expressed as values from 0 to 1. If my tracker is positioned exactly in the center, then from 0 to 1 along X, it's 0.5. That value gets multiplied by the image width. So if I load a proxy, that's half the resolution, 0.5 gets multiplied by the smaller width, and we still end up at the center of the frame. So yes, you can safely load proxy footage without worrying that anything will break during tracking. You can track part of the shot in full resolution, realize it's too heavy to work with, and then switch to a lower res version. The only important thing is make sure the aspect ratio stays the same. So here, I'm loading a JPEG as a proxy. It's lightweight, 8-bit, and it's half the resolution of the original footage. And I can switch between different footage versions. All the trackers will stay in place, but we can work with a smaller image. We can also load a high-pass version where details are enhanced for better visibility. And we can switch between the different versions. Next, the pattern field. This shows the name of our file. Here we have the file path, here's the pattern, and the actual file name. The start and step values mean we're taking the whole shot, starting from frame 1 to frame 88. If we don't need all of them, we can say we're only taking, for example, frames 80 to 82. With a step of 1, that gives us 3 frames. First frame is frame. This is the frame number that's marked as the first frame on the timeline. So right now, this one is marked as the first frame. This is useful when you're working with a huge, long footage that's been clipped from the middle of an even longer source, where the frame count can reach tens or even hundreds of thousands. Here, of course, you can set it up so that your first frame is, say, 1001 instead of 1, which is pretty common. This is especially helpful if there's a chance the usable phase of the shot might later expand, not just forward, but also backward in time. So you don't end up working with negative frame numbers. In that case, many people start at something like frame 997. Or if you're starting mid-shot, you can just say you're working from frame 80 to frame 82. Or from frame 80 to 88, and we also have the step parameter useful for longer shots. If we don't want to track every single frame, we can set it to track, for example, every second frame. Step defines the interval at which frames are selected. Well, by default, this range is set from the first to the last frame, and the first frame will be 1. The rate FPS parameter defines the frame rate of your footage. In other words, how fast frames change in the sequence. It does not affect the tracking process. This parameter only matters when you export the camera from the program, you're playing back the sequence, or you're calculating the shutter. So for example, you can track a shot at 1 FPS, and if you forgot to set it initially, you can just change it later and export the camera correctly. Or say you're working on a slow-moving shot. You might set a higher FPS like 96 just to get smoother playback and work more comfortably. Then, once you're done, you set the correct FPS and export the camera. So again, it doesn't affect tracking. Shutter angle. I'm not sure how relevant this parameter still is with today's cameras. It probably makes more sense with older DSLR cameras where the readout speed wasn't that fast. And in those cases, you could clearly see a large shutter value with noticeable motion blur. But on modern cameras, this kind of thing is quite rare. Still, if you happen to know what shutter angle your footage was shot at, go ahead and set it. Why not? Same goes for the image type parameter. I honestly can't remember the last time I dealt with interlaced footage. I doubt this will ever be needed. Unless, of course, you're working with some really ancient material. Next is the 8-bit color conversion block with the black and white parameters. These define the black and white points of your source footage. Gamma is used when you want to brighten up the dark areas, and soft clip helps recover details in the highlights. Gamma is used when you want to brighten up the dark areas, and soft clip helps recover details in the highlights. If your image has a non-linear gamma, you can absolutely adjust it here as well. By default, EXR files are in linear color space, but in this case, I know it's 2.2 because I converted it incorrectly. The long light conversion option is for 360-degree video, and we won't touch it in this course. It's a rather specific topic, and we won't need it here. Lenses. Even though the structure of 3DEqualizer separates cameras and lenses, in practice what's labeled a camera here is simply the footage you load. And what 3DEqualizer calls a lens actually includes both the physical lens and the camera it's associated with. Each piece of footage must correspond to the camera and lens it was shot with. So if you have multiple footage sources here, multiple sequences or a sequence and reference photos, and they weren't all shot with the same camera and lens, then for every camera plus lens pair, you need to create a separate lens. For example, if we're tracking 2 shots within the same scene, one shot on a red with a 50mm lens, and the other still in the same scene but either with a different lens or even a different camera entirely, then we must create a separate lens object for each of them. So, what's next? Here we choose the lens the footage was shot with. And we select it. Right now, there's only one lens listed. It's unnamed, and yes, lenses should also be named, so this footage is now attached to the lens it was shot with. Next we have 2 parameters, focal length and focus distance. And here it says, use from lens. In most cases you should leave these set as they are. That means the focal length and focus distance values are being pulled directly from the attached lens settings. So here we have the focal length and the focus distance. We can also set the focal length right here by selecting static and entering the focal length we know this footage was shot at. The value in the lens itself will stay the same, but for calculations, it's the value set here that will be used. And there's one more setting available here. It's for zoom lenses or lenses with dynamic focal length. If that's the case, we switch from static to a dynamic option, and the focal length will then be pulled from a keyframed curve graph. Same goes for the focus distance. By default, it's taken from the lens, but you can override it right here without touching the lens settings. Or you can switch to dynamic focus distance and animate it using a curve graph. We'll get to those graphs later. The next block is the distortion grid block. We'll come back to this one. We'll have a dedicated lesson focused on distortion grids, so for now, we'll skip it. Just to mention briefly, the distortion grid is imported as a reference frame, so you create a reference camera and load the distortion grid image into it. This section here is for grid detection mode, either checkerboard or line grid. But again, we'll revisit this block later, so let's not overload our brains for now. Next important section is the camera constraint block. Camera constraint defines the type of camera movement, meaning how the physical camera moved during this shot. By default, it's set to no constraint, which means there are no restrictions on the camera movement. The software assumes the camera could move freely, forward, backward, sideways, plus rotate on all axes. But sometimes we don't have enough trackable points, not enough elements to really grab onto, and as a result the track feels unstable. Not because the tracking itself was done poorly, but because there's simply nothing to track in the frame. In those cases, we can help the software by telling it what type of camera movement we're dealing with, and that makes a huge difference. Camera constraint acts like an axis limiter. By defining how the camera moved, we're telling the program, hey, the camera moved like this, but not like that. Or maybe it didn't move at all, it just rotated in place. When you exclude certain directions of movement, you make it much easier for the software to solve the shot. So, what options do we have? Fixed camera position constraint. This is when the camera is locked in place and only rotates. That means no parallax in the shot. And remember, all tracking is based on parallax on the relative shift of near and far objects as the camera moves through space. If there's no parallax, we can't determine depth or how objects move relative to one another. The next type of camera movement is plane movement constraint. This means the camera moves within a defined plane and can still rotate freely. So we're excluding one axis of translation. The camera moves along 2 out of 3 axes only. We define this by selecting a plane. For example, XZ. That tells the solver the camera moves forward, backward and side to side, but it doesn't move up or down. Again, the more information we give the solver, the easier it is for it to solve the scene accurately. Linear camera movement is similar, but here we exclude 2 of the 3 translation axes. That means we're telling the solver the camera only moves along a single axis. You still select a plane in the UI, but what you're really doing is telling it which axis lies within that plane and should be used. Circular movement, this is often used in a similar way to linear movement. For example, when filming with a dolly, either on straight or curved tracks. Just like before, you specify the plane in which the circular trajectory lies. It doesn't have to be a full circle. It can also describe partial arcs or simply movement along a radius. With a fixed camera, we can also specify the height at which the camera is placed. The parameters below are for locking specific axes, and it doesn't work in a way where we simply assume the camera doesn't move along a certain axis, lock it and then solve. Nope, it works a bit differently. Here's how it works. Let's say you've already solved some camera movement and you got a good result for certain axes either in terms of movement or rotation, but not so much for others. And each time you resolve the camera, the values get reset and recalculated from scratch. If you want to keep some of the previously solved values, you can check the boxes next to the camera transforms or rotations you want to preserve. For example, maybe you've manually adjusted a curve there. You lock those axes, run the solve, and those specific axes will stay exactly as you set them, either manually or as they were after the previous solve. Then, the remaining axes will be recalculated, taking the locked ones into account. That's how it works. Auto tracking, I'd say it's not really what Equalizer is made for. There are other programs where auto tracking is implemented better, like Nuke, Syntheyes, or anything else really. We'll skip it for now so that all the information stays somewhat organized. There will be a separate section dedicated to auto tracking, and that's where we'll break down this group of settings. Synchronization. This is about syncing different footages with each other. You specify which camera is the primary one, which one is secondary, and whether there's any frame offset between them. This applies when you're tracking a specific object that was filmed from multiple cameras. In other words, you're tracking it within the same scene. Next, the stereoscopic block. We won't be covering stereo tracking in this course. Just like 360 degrees, it's a separate topic. I'd say it's a niche case and pretty rare in tracking. And the last block of parameters is rolling shutter. You can turn it on or off, set its values if you're adjusting it manually. There's also adjust toggles. We'll come back to those later. By the way, one of the biggest features of 3DEqualizer is the ability to adjust parameters even if you don't know their exact value. That's what people love Equalizer for. Well, that. And its solver, of course. The time shift parameter is the time it takes for the sensor to read information from top to bottom. If your shot clearly has rolling shutter, then yeah, you definitely want to tune this. If not, I can't remember the last time I dealt with footage where you actually needed to compensate for rolling shutter. It's probably something you'd only see in a low-budget shoot where a cheap camera was used. If you're tracking a film, a music video, anything shot on a proper cinema camera, this is highly unlikely to be relevant. But just in case, this is where it's configured. The second parameter is the distance to the object that shows noticeable shutter distortion. And that's it for the camera parameters. All of this is essential knowledge, widely used stuff, and absolutely necessary.